Hello everyone, this is Mr. Sai, and this video will talk about the structure and bonding of its substances, especially the metals with giant metallic structure. So, if you want to know the physical properties of the metals, why it can conduct electricity, why it has high melting point, or why they will remain intact even they are deformed or elongate into wire, you have to understand the structure and the components inside the structure. As you have seen on the screen, there is a block of sodium metal. So if we can magnify it and observe the structure of the sodium metal, you will see there is tons of sodium atoms. But the sodium atoms are not stable in this state. They have to remove the outermost shell electron to become the sodium ion, that is Na+. And the outermost shell electron that are removed from the atom become the delocalized electron because they can move freely around the metallic structure. So now you see the metallic structure is like that. The particles are indeed the sodium ions, and they are surrounded by a sea of delocalized electrons which are moving around them all the times. And there are the electrostatic attraction between the sodium ion and the delocalized electrons around them because they have opposite charges. And the electrostatic attraction between the ions and the electron are what we call metallic bond. So it is not difficult to deduce that if the metal atom can release more electrons or it have more outermost shell electron, it can form an ion with greater charges, and they will release more delocalized electron in the structure, so the metallic bond will become stronger. Moreover, why we called the metallic structure giant? Because the this structure can be extended unlimitedly, and there can be more metal ions and delocalized electrons on the same layers, and also there can be numerous layers beyond and under the metal layers. Then we can see a larger metal rich structure consists of the metal ions is surrounded by a sea of delocalized electrons. So this is the giant metallic structure. Knowing more about the structure in the metals, we can explain some of the physical properties of the metals. First of all, metals generally have high melting points, which have about 1000 to 2000 degrees Celsius, except those for the group 1 elements. Metals have high melting points because there are strong metallic bonds between the metal ions and the delocalized electron in the structure. Therefore, a large amount of energy is required to overcome the strong bonding between the ions and electrons. Next, metals have good electrical conductivity, or we can say they are good electrical conductor. It is because the giant metallic structure contains a lot of delocalized electrons. They are negatively charged and they can move freely in the structure. So, under the effect of electric field, the delocalized electron will move to one direction to make a current. In the molten state of the metals, that is in liquid state, they can also conduct electricity because the delocalized electrons are still present, and they can flow in the structure to create a current as well. So metals can conduct electricity in both solid and molten state. Thirdly, metals have high heat conductivity. That means they can transfer heat very quickly from one side to another side. It is because there are delocalized electrons in the structure, so when heat is given from one side of the structure, the denuclearized electron will gain the energy and they will move faster. So they will collide with other electrons or the metal ions more harshly. So they will transfer part of the kinetic energy to those particles. So the heat will be spread in such way instead of merely vibration of the metal ions to transfer the energy. Last but not least, metals are malleable and ductile. That means they can be flattened to form a sheet or elongate to form a metal wire under a force without breaking. That's why metals can be made into different shape and size without breaking. And the reason why the metals are malleable and ductile is because there are denuclearized electrons in the structure. That means when there is a force which have breaking the arrangement of the metal ions, the metallic bonds between the metal ions and the denuclearized electron remained intact. Therefore, the metallic structure remained intact, and because the metallic bonds still exist between the ions and the electrons, so the metal do not break. So this is the end of this video. I hope you all could understand more about the giant metallic structure as well as the explanation of the physical properties of metals.